Yeah, this lesson is the first uh, lesson of Unit 2. So in Unit 2, we're going to work on word problems. Now, many students are afraid of word problems. Based on my experience, I found there are two reasons. One is to understand the word in terms of language, like how to dissect a sentence and trying to figure out uh, what does it means. And the second one is the uh, understanding of the math concepts and uh, how to do the math. So by focusing on this head on, and it's really to help us to master the concept of what we have learned in terms of algebra and how to use the methods in algebra, how to find the values unknown, and to master that skill and also have a deeper understanding of those mathematical concepts, and at the same time had a better uh, uh, better ability to understand word sentences. Okay, so so this one for this lesson in which is the first lesson of Unit 2, we are looking at speed, distance, and time. And this is actually what we see that pretty often. Like if you want to go to some place, like say want to go to Washington, D.C., then we have to know how long is the trip. And then we can kind of um, estimate what will be our average speed. And then we get a good estimation about time. And so we figure out, okay, do we have enough time actually to finish to let's say drive 8 hours? Can we get there? Um, things like that. Do we have to drive in just one day or have to drive in 2 days? Okay, so those are kind of very practical. Now, in terms of speed, the first one is the speed. We have definition. Speed is defined. Now, we have this symbol for define. So basically, that's what we mean by speed, which is defined as the total distance that we traveled over the total time we traveled. Now, of course, this speed is something we call average speed. Now, as you notice that if you're driving the car, if you drive, you have average speed, but your instantaneous, that means at that moment, moment by moment, at a particular time, your speed could be way over the average speed or way lower the average speed. It's called instantaneous speed. Like say if you want to go from maybe your home to maybe your favorite place. And so along the way, we might have, if we actually had to go through schools, now the school normally has a pretty low speed limit, so it probably can only go 25 miles per hour. And if you get into, say, interstate, say this part is an interstate, then you might be able to go 70 miles per hour. Okay, but the average is the total distance over the total time. So you can see that your instantaneous speed changes all the time. Sometimes way below your average, speed sometimes is way over. And sometimes you might just take a break. You know, you see those rest stops. You take a break, then you are not, your speed is zero. Okay. So now, given the definition, the speed is distance over time, and normally we write as S equal to D over T, and so just can save time. So if we know the distance, for example, if we drive 100 miles and in 2 hours, then we know our speed is simply 100 divided by 2, which give us 50 miles per hour. So that means each hour we can drive 50 miles. And we did drive 2, so we got 100 miles. And if we say we drove 120 miles in 3 hours, then our speed will be 120 divided by 3, that equals to 40 miles per hour. So this is pretty straightforward. Now, knowing the definition, which speed is distance over time, then we'd be able to figure out if we know the speed and time, we can figure out the distance by simple algebraic maneuver. Okay. So remember when we do algebra, we have, especially when we're dealing with equality, we have basically two properties. One is if A is equal to B, then A plus C equal to B plus C. So this is our called addition property. And the next one is if A equals B, then A times C equals B times C. This, we call that multiplication property. So that's basically what we do. Of course, in algebra, when we say add, that also includes subtraction. We see multiplication, that includes division, because division, well, first of all, subtraction, like say 7 minus 5 is simply 7 add -5. And 7 divided by 5 is 7 times 1/5. Okay, so that's why we just, in algebra, we say we only have those two additions, properties, addition property and multiplication property. So that's what we use if we want to move terms to the other side of the equation. And that's basically what we do algebra, is we put this unknown onto the left equation, then everything else will go to the right. So if we know speed is equal to distance over time, if we know the speed, we know the time, we're trying to find D. D's are unknown. So what we're going to do is we basically flip the equation, which we can do that. That's the proper equation. Then R is like S. Now, we had to move T over. So then we can just, both sides use the multiplication property times both sides. So therefore, what we got here is distance equal to speed times time. So now we have this equation. Now, this equation is definition. Definition is kind of like we give a name to it. When the distance over time, we call that speed. Okay. Now this one is an equation. It's a derived equation. And you can see that that's come from definition from here. Then by using algebra, we can get to here. Okay. So now if we know the speed, let's say we are going, say, 70 miles per hour. Yeah, Well, nowadays people drive a lot faster. Like if you go to I-465, the speed limit is 55 miles per hour, but everybody is driving more than 70 miles per hour. And the police seems okay with that. Okay, so let's say if we're doing 70 miles per hour and we drove for say 3 hours. Now what's our distance? Based on the equations formula, it's pretty easy. The distance, just speed times time. So we got 70 times 3, which has 210 miles. Now this makes sense because 70 mile per hour means that each hour we can go 70 miles. So we got 3 hours. Of course, will be multiplication 3 times 70. So it's basically what we said. First hour is 70, second hour is 70, third hour is 70. Instead of 70 add 70 add 70, 70 add 70 add 70, we just like 3 times 70. That's why we have multiplication. Just make our life a lot easier. Okay, so that's how we find distance. Now let's suppose we do 50 miles per hour. And we also did 3 hours. Okay, so that means if you're going to follow the speed limit, you drive 50 miles per hour and goes 3 hours, that will be 50 times 3, and that will be 165 miles. And you can see the difference. 70 mile per hour versus 50 mile per hour. In 3 hours, we have a difference of 210 minus 175. That's 5 and 4. So 45 miles. That's a difference because our speed is different. So same time, same amount of time, but because speed is different, the mileage we cover is different. Okay, now we find how to do distance over given speed and time. Then what happens if we try to find the time, if we know the distance and speed? So again, we can either use the definition is that, or we can use the derived formula, distance over equal to speed of time. Now, if we use this one, we're trying to find time. So therefore, we want to keep t on the left equation. Everything goes to right. So the s has go to right. Now, in order to do that, we basically times 1 over s. And then 1 over s times s is 1. So that's something we call canceled. Now on this side, now it's d over s. So now we got a formula for time. So therefore, if we know the distance and speed, we can figure out time. So let's see, our speed is 30 miles per hour. And we drove like 90 miles. Now the time then will be 90 miles divided by 30. That gave us 3 hours, which also makes sense because each hour is 30. Now 3 hours, of course, is 90. But now we just use a formula to figure that out. Now, suppose we're doing 45 miles per hour and we drove 135 and miles. So the time then will be 135 divided by 45, and that will give us 3 hours. Okay, now let's look at last one. Let's see if we want to go to Chicago. From my house to Chicago is about 200 miles. And now let's say we're trying to get an average of 60 miles per hour. Then the time it will take us is 200 over 60. which basically is 20 over 6. And we can simplify that. This is a 10, as this is 3. Okay, so we got 3 and 1/3. Okay, so 3 hours and a third of an hour. So a third of an hour is 20 minutes. So it'll take us 3 hours and 20 minutes to get to Chicago. Okay, so you can see that knowing how to use those 3 formulas, we can basically figure out time, distance, and speed. Okay, now those are basically help us to understand the relationship between speed, time, and distance. So now knowing that, then we can do something actually a lot more interesting. Like, for example, let's see, let's just have a person. Let's say the person is David, and he drove from city A to city B. Now it takes him 65 miles per hour. And then came back from city B back to city A. He's driving 50 miles per hour. Now, the total time is 24 hours. So we're trying to figure out what's the distance between those two cities. Okay, well, this now, since we can do algebra, we'll be able to translate that into from the this word sentence into equations. So that's basically the the things we do when we're solving word problems is basically the first thing we have to do is do the translation. So from English to math. Okay, so let's translate. Okay, we don't know how long it will take from A to B. Let's just call X. And we don't know how long go from B to A, but we know the total is 24. So going back should be 24 minus X. And we also know that the distance from city A to city B is the same as from city B to city A. So therefore, we'll be able to set the equation. And this is what we're trying to get. Once we set equation, then we're just solving it. So now the distance from A to B, we know is speed times time. So it's 65 times X. The other side, speed is 55. The time is 24 minus X. Now we can just do distribution right away, or we find something make a bit life easier is to know that 65 is a multiple 5, 55 also multiple 5. So we can just divide 5 on both sides. Because it's equation, we can add, subtract, multiply, divide, whatever in whatever which way that we want to do. But of course, we have to know the reason we do that is trying to find X. Okay, so we got 13X equals to 11 and times 24 minus X. So now we're going to distribute that. That gives us 11 times 24 minus 11X. So normally I don't multiply until the end. Okay, and typically save time. So now we have to find X. So, but to do that, we have to move all the X to the left. So this 11X needs to move over. But to move over, we just add a subtract. So in this case, we just add 11X on both sides. And then on this side, of course, they cancel. Minus 11X plus 11X is 0. On this side, we got 24X. And outside, we got 11 times 24. Now you can see why I didn't multiply that until the last step. So we divide by 24, then divide by 24. So now make life a lot easier. I just cancel. So X is 11 hours. So now we know going from A to B, take David 11 hours, and going back from B to A, take him 13 hours. So add together will give us 24. And that's what is given in the problem. Yeah, we have that. Okay, but we're trying to figure out the distance. So distance then will be, we can either use this or use that. Really doesn't matter. If we use top one, the distance then will be 65 times X. Now X is 11. So that will give us 715. So we've got that 715 miles. Okay, so this is a kind of speed, distance, and time problem. All right, now we're looking at another one. Another one is that, let's see, we have, let's say a family, it's travel, and first the dad is driving. Let's say dad likes to drive faster, and the second half, mom driving. So the first half, dad's driving at 65 hours, 65 miles per hour. And then after that, we got mom driving, and mom drove at a little bit slower, say 60 miles per hour. And we know the total. The total time is let's say, is 13 hours. Let's make that a little bit interesting. Okay, and we want to find the total distance. Okay, so we know the speed from here to here, which is half the distance, and here to here is half the distance. So now, if this, for the first half, we spend X hours, then the second half will be 13 minus X hours. So that's pretty, okay, that's some, oh, okay. So therefore, the distance from here to here will be 65 times X. And from here to here is 60 times 13 minus X. Now we know, because we said it's half the distance, and this two halves, so they are equal. So now what we got here is this equation. Again, we notice that it's divided by 5. So we divide by 5 and here. So we got 13x equal to 12x, 13 minus x. And that we go into distribute it. We got 12 times 13 and minus 12x. Then we add 12x, because we had to move all the variable unknown to the one side. So we got 25x equals to 12, 13, and 25. Oh, sorry. 25x equal to 12 times 13. And then, of course, we can just divide 25 on both sides. And that cancel. So x is 12, 13 over 25. Now, we can do 12 times 13 times 25, or we can play this trick. We can do times 4 over 4. 4 over 4 is just 1. So we didn't, we won't change the value, but we change how the thing is done. Notice that on the bottom, that's simply 100. the top, 4 times 12 is 48 times 13. So all we need to do is 48 times 13, then we move decimals by 2. And that, so we don't have to do a divide by 25. And multiplication is normally easier. So 48 times 13, we got 3 times 8, 24. 3 times 4, 12, plus 2, that. Then 1, 8, 1, 6, we got 4. And here we got 12. Then we got 6. Okay, so now we are equals to 624 over 100. So therefore, it's going to be 6.24 hours. Okay, of course, then that's that. Mom driving will be 13 minus that. So, and you're going to take mom a little bit longer because mom drove a little bit slower. So that will be 13 minus x, that give us 6.76 hours. Okay, but this is not what they want asking. They're asking for the distance. So therefore, we look at the first half, then we times 2. So first half is 65 times 6.24. Let's see how many hours is that. And then we're going to times 2. Because this just, the distance that drove, that's just half of that, times 2. So therefore, we got 2 times 65. You can see what we have. 2 times 65 is 130. And 6.24. So now you can see that it's a lot easier now. So basically, this is just 13 times 62.4. Now 62.4 times 13. We got 3 times 4, 12. 3 times 2, 6, plus 1, 7. 3 times 6, 18. Then 4, 1 times 2, and 6. We got 2 and 11, and that's 11. So it's 811.2 miles. So that's how we find out the total distance is that. Okay, as you can see that understanding the relationship between speed, time, and distance, and then we can use that to solve some those kind of interesting problems. And there are more of that, and interesting problem like that, dealing with speed, distance, and time. And that's something we're going to learn more next time. Okay, bye.